All right, here we go. Lesson 4.2, homework help. Let's get it started in high. We've got solving systems of equations by the substitution method. So we don't have to graph, we just substitute. Let's go over this one slowly and then we might be able to speed up a little bit more as we move on. I am going to ask you guys some questions, so be prepared. Tell me, do you guys know what an expression is? Do you guys know what the difference between an expression and an equation is? What?
An expression doesn't have an equal sign.
Very good. An expression is just something like this. Something like this, or like, that's an expression. Any form of terms being multiplied, added, divided, whatever, but it's not set equal to anything. It's just an expression. It's kind of like the difference between a sentence, which is a completed thing, like an equation, and an expression would be kind of like a part of a sentence, or what we would call a phrase. Like, in the bathroom would be just a phrase. But if I said, she is in the bathroom, that would be a sentence. So an equation has an equal sign, and it has something on both sides. It can have variables, that's fine, but this is an equation. An expression could look something like that with no equal sign. Okay, do you guys understand that? Melanie, were you paying attention to that? Because I do have a question for you. Were you paying attention to that part? Okay. So when I go over some things before I go to the question, I really want everybody to pay attention. It kind of looks like you're trying to skip ahead instead of pay attention. Can you pay attention, please? Melanie, can you pay attention? Can you respond to me, please? Thank you. So, Melanie, can you tell me what expression is equal to y? I'm going to give you a hint. The first equation says y equals 2x plus 1. So what expression is equal to y? I'm going to give you a hint by saying it's a very simple answer. Everything's up there. I'm not asking you to do any crazy math in your head or anything like that. I just want you to identify the expression that is equal to y. What is it? That's it. The expression that is equal to y is 2x plus 1. Very good. Do you not like candy?
Where's my candy? I answered the expression and equation one.
That's true. You like lemon heads? They're chewy.
Yeah, sure.
Sorry, terrible throw. What?
Okay.
I know. I'm gonna just like really send somebody to the hospital one day with like a damaged eyeball.
You had lotion in the head today.
I did, but you know what? It's okay. If it's candy, it's okay. If it's something else, then maybe not. I think everybody forgives me because it's just candy. Okay, so this is the expression that is equal to y. If this expression, 2x plus 1, is the exact same value as y, then I can use it to replace this y. If they're the same thing, then I can use them interchangeably, which means if I don't want this y to be here anymore, I can get rid of it and replace it with this expression. Why would I want to do that? Just to make things more complicated? Yeah. It actually makes it simpler. I'm going to write out my new equation and you tell me why it's simpler. So I got rid of the y and I'm replacing it with this expression 2x plus 1. What's really important for this? Before I write 2x plus 1, what do I have to do? Parentheses, very good. And I'm using parentheses because that's indicating that 5 is being multiplied by this expression, just like 5 was being multiplied times y. So do you agree that 5y is the exact same thing as 5 times 2x plus 1?
Sure.
Okay, now I'm done writing 5y. Now I'm going to continue my equation. Minus 7x equals 11. Now, why do you think this is going to be easier to solve than this? It's much longer, it looks more complicated, but why is this going to be actually easier to solve than this?
Math is really well.
Does anybody know why this longer, more complicated looking equation can actually be solved? But this equation cannot be solved.
Well, what?
What's the difference between this equation, 5y minus 7x equals 11, and this equation, 5 times 2x plus 1 minus 7x equals 11? Yeah.
Because you can do the parentheses first, so you get
It's not the parentheses that, but good guess.
distribute.
We will distribute, but I'm asking why? What is the benefit of rewriting this equation?
So it's easier.
What?
You're not solving anything. Well, like, because if you do, because you don't know if you do the 5y minus 7x equals 11, you have to solve for either y or x. It's not giving you that.
Yeah, and if I take 5y minus 7x equals 11, if I try to solve for it, my question would have to be, well, which variable am I solving for? There are two different variables. So if I solve for y, I'm going to end up with an expression.
Is it for like an easier equation so you can solve it quickly?
Why is this easier though?
Because you could get rid of
Kind of.
Because we don't know the
We can solve for x and get an actual number value. Because there's only one variable. Now you see it twice because we haven't combined our terms yet. But we have the same variable. So I only have one actual variable to deal with and to solve for. With this equation, I can't solve for the number value of y because I'll end up with an expression that includes x. If I solve for x, I can get x by itself, but it will be equal to an expression that includes y. I'll never be able to solve and get a number. But if I replace the y with an expression that has an x variable, I'll be able to, after I distribute, I'll be able to combine it with the other x term and then solve for x and get a real number value. That's why we want to do it, because we can actually solve and get our x value. Remember that getting a solution to a system is an ordered pair. So we need an x value and a y value. What are we going to solve for first? Which variable are we going to solve for first? X, because that's what we subbed in for y, an expression that includes x. Now we can distribute. And we get 5 times 2x is 10x times 5, plus 5 times 1 is minus 7x equals 11. What do we do next?
Combine like terms. 3?
Combine like terms, and I get a positive 3x, a 10x plus a negative 7x. You just subtract the 10 and the 7, take the sign of the bigger absolute value, and we get 3x plus 5 equals 11 minus 5 from both sides. 3x equals 6, divide by 3 on both sides, x equals 2. Is it okay that I went quickly through that? That's that's a skill that we should all have mastered by now. So, did I solve it?
No.
I solved for x, but did I solve for the whole system? No, I just have half of it. I just have
Do you know to do the same thing but replace x with y?
replace x with y.
To find what is
I definitely could. It would be an extremely complicated way to solve for y. Instead of doing that really complicated way, I can take my x value, that's 2, and I can plug it into this equation and substitute x with the value that I found for x. So I have 2 times 2 is, plus 1 is 5. So y equals 5. Am I done?
No.
I mean, technically I found my solution, so I can be done. But if you want to be super sure, what do? Plug them back in to the original and make sure that solution works for both. So y would be 5, 2 times x would be 2 times 2, plus 1, we're just going to double check, 2 times 2 is 4, plus 1 is 5, we're good. This one's a little more tricky, so 5 times y would be 5 times 5, minus 7 times x would be minus 7 times 2, equals 11. Make sure you use your order of operations. You have to multiply first, 25, and a negative 7 times 2 is negative 14, equals 11. Does 25 minus 14 equal 11?
Yeah.
It does. So it checks out. So the answer would be A, and then the solution, watch what it says. It says simplify your answer, which it's already simplified. It says type in ordered pair. Make sure you type it with your parentheses. Do you have the same system here, or do you have a different system on yours? You have the same one?
No.
Oh, you have a different one?
I have a question. So,
Yeah.
you just like, am I just want to graph this? Because I really don't feel like this.
So these are not, this is in slope-intercept form, but this one's not. Do you really feel like it would be easier to put this into slope-intercept form, then graph both of them, then find the point where they intersect, then check that answer and plug them back in? I don't think that is the best way to do it. And since we're learning about substitution, I would like you to solve by substitution, okay? Yes, Emily?
So for me, I had the first equation as you, same as you,
Okay,
but not the second one.
okay.
But I have the same like answer as you.
Same solution? What did your second equation look like?
It was 3x minus 3x equals 9.
Couldn't be, couldn't have. What did your first one said y equals 2x plus 1, and your second one said what?
3y.
Oh, you said x. 3y
3y minus 3x equals 9.
equals 9? Okay, and did you do 3 times 2x plus 1
Yeah, I did it the same as you. And
minus 3x? I just want to see if it works. It could work, let's see. So then did you get 6x plus 3 minus 3x equals 9? Oh, did you already submit the answer? Did you check it? And it was right? Oh, okay, good. Then I won't even check your answer. Good job. All right, we're going to move on to number 2. Same exact question, just with a really annoying fraction in there. So we need to use our fraction rules, be very neat and very careful. Which of these equations in the system gives you an expression that is equal to a single variable? Which of these equations in the system? What?
The first one.
The first one?
No, the second one. Since it only has 2 numbers.
It doesn't have to do with how many numbers it has. It has to do with a variable being isolated. And on the other side of the equal sign, it's just an expression. It doesn't matter what the expression is. Hands up. Is that homework? Okay. What number are you working on? Did you get it incorrect? Are you doing help me solve this? Are you not understanding are you paying attention to what I'm doing? Okay.
I think I already did that question. I did that first and second.
Okay.
So I'm just doing that.
All right, just keep in mind that I expect 100% on this homework if I am doing it with you, okay? So if you're gonna move ahead of me, that means you better get 100% or else we cannot go ahead, all right? So Emily, you are correct. It's the second equation because y is by itself. So this expression, negative 1/3 x plus 5, is the same value as y. Therefore, we can use it to substitute this y. So I'm going to rewrite this top equation, 2x plus 6 times y, which we're substituting in this crazy thing. I'm going to open up some parentheses. I have negative 1/3 times x plus 5, close parentheses, and then I'm going to continue writing the equation equals negative 18. Now what do we do?
Just solve it.
Simplify, yeah, simplify and solve. What do we do first?
Do we add 2x to 6?
No.
Yeah, but. Oh!
Distribute. So we do 6 times negative 1/3. So I'm going to put 6 over 1 for that, and I'm going to cancel out my 6 and my 3 by dividing each of them by 3. And I get 2 times a negative 1, which 2 times a negative 1x, which is
2x minus.
no, 2x minus 2x, right? 2 times negative 1 is negative 2, and then x is x. And then I have it, now I'm going to uncross out my 6 here. I only crossed out the 6 because I had to cancel my fraction, but now I'm going to do my original 6 times 5 is 30. Is anybody paying attention?
Yeah.
30 equals negative 18. What's next?
Wait. Take off the 2x.
What do you mean take off the
Get
2x?
rid of it.
What?
Get rid of it.
Get rid of what? You're onto something. We did this. If you have not had my class yet today, then you have not seen a problem that's exactly like this, but we're going to work through it together, and then you'll get another example of it later in class. But Abby, you were there. What happened, Abby, when we had a term, and then we subtracted the same term? What happened? If you have a value, and then you take away that same value, what do you get?
Nothing.
Exactly. You get nothing. So this goes bye-bye. It doesn't matter what my x value is. X could be 5, x could be 10, I don't care. If I have 2 x's, and then I subtract 2 x's, my x's go bye-bye, right? So that means that 2x minus 2x is 0 plus 30. That means it's just 30. Now look what we're left with. We've gotten rid of our x terms, they disappear. This is really important if you haven't taken my class yet today. This goes bye-bye, it canceled itself out, and then we have 30 equals negative 18. So this is really weird, and again, if you haven't taken my class, Abby and Ricky have, but if you haven't been there yet, you're gonna see examples like this when I finish the lesson. The variable that we're trying to solve for canceled itself out. We're left with a statement that isn't true. We're left with a statement that isn't true.
No solution.
Correct. No solution. If we're left with a statement that is not true, then there is no solution. So what do you think these lines are? How could we describe these lines if there's no solution? Parallel. Very good. So we would choose there is no solution. If you get a statement in the end that eliminates the variable and it's not a true statement, that means there's no solution. Okay, it says consider the systems of equations. Here you go, Abby. Now we're going to graph, okay? On number 3, it says consider the system of equations. First, we're going to solve this system of equations by graphing. So I'll go ahead and graph them first.
Why does it say 23
Because,
no little question?
oh, because when I customized the homework, I took out so many of the questions that these technically, like, there are like 30 questions on the original homework, but I removed most of them, but they still kept the same number. So this, I still think this is like number 3 or something.
Can I rewrite them?
What?
Can I rewrite them?
Yeah. All right. So, I don't like how they blur this out a little bit, but if I'm going to, it says to solve them by graphing. If I'm going to graph them, what do I need to do first to these equations?
Put them in the solution form.
Slope-intercept form. Okay, and that means I have to solve for y. Very good. So if I'm solving for y, I need to get, I'm going to just do it over here, x plus y equals 4. That means I need to get rid of my x, subtract x here. That's gone, and I have y equals, which term should I put first, my negative x or my 4?
4.
Why? Negative x, we want our x term first because it's our x term that has our slope. So we have this in perfect slope-intercept form. Let's graph it. What's the y-intercept?
4.
Okay. So I'm going to do 4 on the y. Okay. And then what's my slope?
Negative 1.
Negative 1. So that means I'm going to go down 1 over 1. That's all I have to do for that. Now I have to do my next line, and I have to get that one into slope.
I don't get how you did that.
What, the negative?
Yeah, I just took the y, I did y equals 1 over 1. Wait,
No, so y equals negative x plus 4.
Yeah.
If you don't see a number in front of x, that means there's a 1 there. It's just invisible because, and if you see a negative, it means it's a negative 1. So if that helps you, you can just write a 1 in there to make it show up. Then remember that a slope of negative 1, if the slope equals negative 1, and we want to put that into a rise over a run form, we just put it over 1. Because every number can be put over 1, and it's the same number, it's the same value. So we go down 1 and to the right 1. And that's what I did there.
So for the second one, I could do it how I did it, right?
The second one?
So I would do y equals 2x minus 5.
Let's see. If I subtract 2x from both sides, I have negative y equals negative 2x plus 5. And then did you divide by a negative? Because you have to get rid of this negative next to the y. Y is being multiplied times a negative, so we divide it by a negative. And then we have to divide each of these terms by a negative. So I get y equals negative divided by a negative is positive 2x. Positive divided by a negative is negative 5.
So I did do it right.
So you got the answer, but I'm not sure if you got it because you did it correctly or you just, it's a coincidence. I don't know.
No, because I just took the y, I looked at the equation, and I said, okay, so it's going to be y equals 2x minus 5. And then
How did you know that it was going to be minus 5?
Because the minus.
The minus is,
Yeah, so I just put the minus.
Okay. I hope it works for you every time you have to solve like that. I personally cannot do that in my head, so I write it out like that. But if you can do it in your head and it works every time, go for it. Maybe have like a special superpower. Okay, so now I have my equation here, and I have to graph it. I have a
the first one didn't work.
The first one didn't work. Okay, so now we're gonna graph my negative 5 on my y. Okay, and then I have to go up to and to the right 1. So now I have my solution. Let me just Oh, it's not gonna let me go in? Okay, so I have 1, 2, 3, 1. So my solution is 3, 1. Let me see if I can save this. Okay, check answer, make sure we did it right. Well done. Okay, so for the 24 it says, now use the substitution method to solve the equations. If I use the substitution for the same system, will I get the same solution? Yes, I should. Let's try it. Is any of these, are either of these equations solved for a specific variable? No, they are not. Which one would be really easy to solve for? Which the first one. We could just subtract the x, right? Actually, I'm going to subtract the y, and I'm going to solve for x, and it will be easier. So I'll subtract the y, and then I'll get x equals 4 minus y. Do you guys agree that that's true?
No. Yeah.
So if I want to solve for x here, which it doesn't matter, you can solve for x or solve for y. I'm just noticing that I want to solve for, it's just my choice, I want to solve for x because if I solve for y, then I'm going to have an expression in parentheses with a negative. I'll have to distribute the negative, it'll be a pain. So I'm going to go ahead and solve, can you put that there? Solve for x by subtracting y on both sides, and then I get 4 minus y, or I could have a negative y plus 4, either way. Then I'm going to take my second equation and I'm going to rewrite it, but instead of having an x, I'm going to substitute it with the expression that's equal to x, because then I'll only have to deal with y's. So I have 2x, but instead of writing x, I'm going to write 4 minus y, and then I have a minus y equals 5. What do I do next? Melanie, are you following along with this at all, or are you just doing it on your own? You are? Okay. I do what? I do the parentheses? Okay, what's 4 minus y? I'll give you the answer. 4 minus y. 4 minus y is 4 minus y. I cannot combine those terms. I can't do anything with it. So the parentheses are done. No, 4 minus y is not 4y. Distribute. Distribute. And I get 2 times 4 is 8. 2 times negative y is? Minus 2y. And then I have a minus y equals 5. What do I do next?
You're going to have to get rid of y.
Not yet.
Get rid of the h.
No.
Get rid of the 2?
No, don't get rid of anything.
Why did you turn British?
Stop trying to get rid of anything. We're going to combine our terms.
Oh.
We have a negative 2y and a negative y. What does that make?
Negative 3.
Negative 3y equals 5. What do I do next?
You have to get rid of the 8.
Get rid of the 8. Minus 8, and I get negative 3y equals, what's 5 minus 8?
Negative 3.
Negative 3. Divide by negative 3, divide by negative 3, and y equals?
It's 1.
Y equals 1, just like I had up here.
This way.
Yeah?
You realize it says do not simplify, right? Scroll down and it says do not simplify right below the answer box.
Enter the unsimplified. The first step is to substitute the value of y from the first equation to the second equation. Enter the unsimplified equation. Oh. Are you serious? So I'm doing this all for nothing?
Yes.
Thank you for catching that. Worst thrower of candy ever. Sorry.
I'm trying to hit the projector.
I was trying to get it all the way over to you and hit the ceiling. Okay, so it says, wow, I should have read all the directions. Use the substitution method to solve the system. The first step is to substitute the value of y from the first equation into the second equation. So, oh, you guys, I substituted x. I have to go back. I substituted x with the value of y. Oh my gosh. had to get that expression. So it says, substitute the value of y. Okay, so now we have to subtract x. Wait, didn't we do that? No, I didn't. Okay, subtract x from both sides, and we get y equals 4 minus x. Now I can replace my y value with this expression 4 minus x. 2x minus y would be minus open parentheses, and y is going to be exchanged for 4 minus x equals 5. So unsimplified, that's what it should be. It better tell me it's correct. Okay, so it says 2x minus 4 minus x. Do you guys have the same numbers as me?
Oh no.
Oops. Equals 5. They better tell me this is correct. Yay! Are you guys understanding the process here?
What? Oh,
It says it's correct.
I don't know. What?
What is the solution to the system, which we already got? Was it 3, 1? When we did it by graphing, it was positive 3, 1, right? This is mine.
Yes. I got it right.
All right, next.
Well, that's obvious because we already have one.
Did I not complete something? Oh, choose the correct answer. It says, what is the solution? Choose the correct answer below. It says, which method is most appropriate to use in this instance? So substitution is the only method that would be appropriate to use here because it's not possible to graph. Substitution is the only method that should be used here because the answer involves integer values. Graphing is the only method that would be appropriate. Graphing and substitution are appropriate to use here because the answer involves integer values. What do you think?
A.
So you think substitution is the only method, but we solved it by graphing?
No. Go ahead.
I think we didn't finish solving the substitution, but we totally could have. I would say it's both.
No.
Is it wrong?
Is it?
It says it's right.
What is it?
Graphing and substitution.
What is
It basically says which method, it says which method you prefer, but then it, yeah. Okay, so now it says, for the next one it says, identify whether each system of equations has infinitely many solutions or no solutions. So, it says solve by substitution. Oh good, it's already solved for one of the variables. We have an expression that is the equivalent value of x. That means I can take this top equation and instead of writing 3x, I'm going to write 3x. But my x is going to look like this. Negative 3y plus 4. Do you guys understand that? Instead of writing this 3x, it's now looking like 3 times negative 3y plus 4. You guys totally get that? Okay. Then I continue by writing plus 9y equals negative 5, and then we just have to solve. 3 times negative 3y is negative 9y. 3 times 4 is positive 12. Then I have to add my 9y equals negative 5. What do I do next?
You're going to have to get rid of, you combine my terms.
Combine my terms. What's a negative 9y plus a positive 9y?
Negative 0 or no.
It's 0. What's negative 9
Zero.
plus 9? It's 0. What's 0 times y?
0.
What's anything times 0?
That's 0.
0.
Yeah.
Good. So what just happened to my y term?
Let's get.
It just got
It's
obliterated.
gone.
It's gone. It's like a magic trick. Poof! They just canceled each other out, and I wasn't even trying. If I cancel those out, I'm left with the equation 12 equals negative 5. Is it a true equation or a false equation?
False.
False. If the equation is false,
There's no solution.
there's no solution. There we go. False statement, no solution.
And then the next one is going to be, actually, I can't say.
Yeah, we're probably going to have to just substitute. I'm going to go through it a little bit quickly because we've gone through the method very many times, but we'll see what happens in the end. Okay, oh good. It's solved for y right here. Oh no, it's a fraction, that's going to get ugly. But I'm going to take this expression that's the same as y, and I'm going to plop it right there when I put in my y, okay? So we have 4x minus 7 times y, but I'm going to use my 4 over 7x minus 5, close parentheses, equals 35. All right, let's distribute. We have a negative 7 times 4 over 7. That's going to cancel out my 7s, and I'll have a negative times 4x is what? Am I going too fast when I distribute there?
No.
You're okay? All right, so if I cancel out my 7s, because 7 over 7 is 1, so it's going to be negative 4x. And then I have a negative 7 times a negative 5.
Oh.
Remember, if I cancel out that 7, that's only for this term. I need my 7 back. So I'll get a positive 35 equals 35. I have my 4x, and my negative 4x gives me nothing. This gives me nothing. So I'm left with 35 equals 35.
For me, I got it. So for my equation,
I'll help you in just a second. Let me get through this so I can get through that next problem. I promise I will go back to yours, okay? Do you guys see how poof, it's gone?
Yeah.
I end up with an equation that says 35 equals 35.
Yeah,
It's a true equation. We actually call that, and you're going to learn this all in your class today, it's called an identity when you have a number equaling itself. It's looking at itself. So when you actually have a number equaling itself and you've canceled out your variables, it's true, so it's infinitely many. Very good. You know all the stuff, and you haven't even had my class yet, so you can teach it later. You okay?
Oh no.
On camera. Just kidding.
Actually, I'd like to do it on camera.
You want to try?
Yeah.
All right.
I'll try, but not the whole thing.
Not the whole thing. Okay.
You have to help me.
I'll help you.
Yeah.
Are you in 6 or 7?
6.
Okay, perfect. That's what's important.
And then I will.
All right, this is the last one. It's a tiny baby word problem that we have to interpret and write some equations, okay? Richard and Teo have a combined age of 48. Richard is 15 years older than twice Teo's age. That's complicated. How old are Richard and Teo? Okay.
No, we're going to divide.
No. Let's organize two different equations. The first sentence gives me my first equation. Let's use R and T to represent the ages of Richard and Teo. We don't have to use X and Y, we can use R and T, okay? Because we're not gonna bracket, we're gonna use substitution. So R and T have a combined age of 48. How do I write that as an equation?
R plus T equals 7.
Yes. Equals 48. Very good. R plus T equals 48. Boom, I've got my first equation. Then it says Richard is, do you guys know what is means?
Like is, like still is.
If I say 3 plus 2 is 5, what does is mean?
It's just
What does it mean in the math? A math symbol. 3 plus 2 is 5. Equal. Yeah. So if I say Richard is, then it's Richard equals, okay, Richard equals 15 years older. What does older mean?
like old.
Like older in terms of like math. Does that mean I'm going to add 15 to this or subtract 15? Richard is 15 years older or more than, so it's going to be, we're going to be adding 15 to twice Teo's age. How do we write with a term twice Teo's age?
That's times.
Yeah, it would be.
X 48.
So remember that Teo we're representing with T, and I need twice T. twice Teo's
Oh, you
age.
could do T parentheses 48x.
No. I just want an expression to represent twice Teo's age. That's all I want. Twice Teo's age. Do you agree that that means it's Teo's? No x and y. We're going to use the variable t. T is Teo's age. How do I write an expression that is twice his age?
Times.
Yeah. Times what? What does twice mean?
2.
Yes. So 2 times Teo's age. Do not back up. I'm not done.
2t.
2t, that's it. Okay? I want you to be able to interpret that. So we have Richard's age equals 2 times Teo's age plus 15, because he's 15 years older than this.
Yeah.
So now we have something that's solved for r, so we can use this expression and plug it in right here for r. So instead of r, I'm going to write 2t plus 15 plus t, right? I'm using this expression for r, and then plus t equals 48. Let's simplify here. We've got 2t plus t. What's that? What's 2t plus t?
2.
No, 2t plus another t would be, Emily, 2t plus another t would be what?
2t.
2t, and then add another.
4t.
Okay, if you have 2 t's.
Oh, 3t.
Thank you. 3 t's plus 15 equals 48. Next step.
Well, you're gonna have to get rid of the 10.
Yeah, minus 15, so I'm gonna write it over here.
33.
3t equals, is that, yeah, 33.
3t.
Divide by 3, and you get t equals 11. So how old is Teo?
11.
11. So Teo is 11. Now we have to figure out how old Richard is. Let's use the really simple equation. Okay? If Teo is 11, I'm going to substitute the value 11 for Teo. And what number plus 11 is 48? Just subtract 11 from both sides, and you get 37. Are you guys not like, I'm trying to let you guys go to lunch. What's 48 minus 11? 37. 37. Don't you guys want to go to lunch? It started 2 minutes ago.
Well, I'm staying here to see if you.
I can definitely help you. I know you do, but like nobody's helping me. Yeah? Everybody can go unless you want to stay. Okay?